All right, let's take on problem 50 on page 295. You have been asked in your homework to take on problems 48 and 49. So 50 is a sister to 48 and 49. And they're all associated with finding domains of logarithms. And in this case, we're asked to find the domain of g of x, which is 1 over the natural log of x. So let's parse this problem a little bit. Let's, there's a lot of ways that we could do it. I'm thinking of one which might be more instructive than others, but maybe not the best way to do this. I don't know. Let me draw a Cartesian plane. And rather than drawing natural log of x, let me draw e to the x here. Right? So e to the x is a function that has an asymptote on the x-axis, and it takes off through this point 0, 0, 1. This is y is equal e to the x. Now, I'm going to now draw the line y equals x as well. There's y is equal to x. And I've drawn these two functions because, and that's a mess, huh? This is y is equal to e to the x here. This is y is equal to x. I've drawn these two because log of x, I'm going to take this g of x one step at a time. Let's look at log of x. Log of x is an inverse, or is the inverse to the function y is equal to e to the x. And as such, their graphs will be symmetric about the line y equals x. So I'm struggling here to draw a good version of that. But if this is e to the x and this is the line y to the x, if I spin e to the x around it, there's the function y is equal to the natural log of x. So we can kind of see immediately that the domain of the natural log of x is equal to all x from 0 to infinity, not inclusive of the endpoints. Yeah. So with that information, let's go ask what is g of x, and I think you can see pretty quickly that the domain of g is almost all the same as log of x, but it includes, log of x includes this point, which is 1, 0, and after all, that's because 0 is the number that you put on e in order to get 1, and given that log of x can be equal to 0, we can't put it in the denominator. So the domain is all x such that, it's all, how do I write it like this? It's all x such that x is greater than 0 and x does not equal 1. Another way to write that might be an equivalent way, it's the open set from 0 to 1 union the open set from 1 to infinity. Okay. Moving on.